In this video we are going to learn about diode and their types. So, a diode is the simplest two-terminal unilateral semiconductor device. It allows current to flow only in one direction and blocks the current that flows in the opposite direction. The two terminals of the diode are called as anode and cathode. The characteristics of a diode closely match to that of a switch. An ideal switch when open does not conduct current in either direction and in closed state conducts in both directions. Ideally, in one direction that is indicated by the arrowhead diode must behave short-circuited, and in another one that opposite to that of the direction of arrowhead must be open circuit. By ideal characteristics, the diodes is designed to meet these features theoretically but are not achieved practically. So the practical diode characteristics are only close to that of the desired. The diode operates when a voltage signal is applied across its terminals. The application of a DC voltage to make the diode operate in a circuit is called as biasing. As already mentioned above, the diode resembles that of a one-way switch, so it can either be in a state of conduction or in a state of non-conduction. The on state of a diode is achieved by forward biasing, which means that positive or higher potential is applied to the anode and negative or lower potential is applied at the cathode of the diode. In other words, the on state of the diode has the applied current in the same direction of the arrowhead. The off state of a diode is achieved by reverse biasing, which means that positive or higher potential is applied to the cathode and negative or lower potential is applied at the anode of the diode. In other words, the off state of the diode has the applied current in the opposite direction of the arrowhead. During on state, the practical diode offers a resistance called as the forward resistance. The diode requires a forward bias voltage to switch to the on condition, which is called cut-in voltage. The diode starts conducting in reverse biased mode when the reverse bias voltage exceeds its limit, which is called the breakdown voltage. The diode remains in off state when no voltage is applied across it. A simple PN junction diode is fabricated by doping P and N type layers on a silicon or germanium wafer. The germanium and silicon materials are preferred for diode fabrication because they are available in high purity. Slight doping like 1 atom per 10 million atoms of the desired impurity can change the conductivity to a considerable level. The properties of these materials change on applying heat and light, and hence it is important in the development of heat and light sensitive devices. The other variant of diodes have different construction, characteristics and applications. The different types of diodes are small signal or small current diode. These diodes assumes that the operating point is not affected because the signal is small. Large signal diodes, the operating point in these diodes get affected as the signal is large. Zener Diodes, this diode runs in reverse bias condition when the voltage reaches the breakdown point. A stable voltage can be achieved by placing a resistor across it to limit the current. This diode is used to provide reference voltage in power supply circuits. Light emitting diodes, LED, this is the most popular kind of diode. When it works in the forward bias condition, the current flows through the junction to produce the light. Photodiodes, the electrons and holes are generated as light strikes across the PN junction, causing the current to flow. These diodes can work as photodetector and are used to generate electricity. Constant current diodes, this diode keeps the current constant even when the voltage applied keeps changing. It consists of JFET, junction, field effect transistor, with the source shorted to the gate in order to function like a two-terminal current limiter or current source. Schottky diode, these diodes are used in RF applications and clamping circuits. This diode has lower forward voltage drop as against the silicon PN junction diodes. Middle dot Schottky diode. This is a 4-layer diode which is also known as PNP diode. This diode is similar to thyristor where the gate is disconnected. Middle dot step recovery diodes. This semiconductor diode has the ability to generate short pulses and hence it is used in microwave applications as a pulse generator. Middle dot tunnel diodes. This diode is heavily doped in the forward bias condition that has a negative resistance at extremely low voltage and a short circuit in the negative bias direction. This diode is useful as a microwave amplifier and in oscillators. Middle dot Varactor diodes. This diode works in reverse bias condition and restricts the flow of current through the junction. Depending on the amount of biasing, the width of the depletion region keeps varying. This diode comprises of 2 plates of a capacitor with the depletion region amidst them. The variation in capacitance depends upon the depletion region and this can vary by altering the reverse bias on the diode. Middle dot pin diodes. This diode has intrinsic semiconductor sandwiched between P-type and N-type region. Doping does not occur in this type of diode and thereby the intrinsic semiconductor increases the width of the depletion region. They are used as autodiodes and radio frequency switches. Middle dot laser diode. This diode produces laser type of light and are expensive as compared to LED. They are widely used in CD and DVD drives. Middle dot transient voltage suppression diodes. This diode is used to protect the electronics that are sensitive against voltage spikes. Middle dot gold doped diodes. These diodes use gold as the dopant and can operate at signal frequencies even if the forward voltage drop increases. Middle dot super barrier diodes. These are also called as the rectifier diodes. These diodes have the property of low reverse leakage current as that of normal PN junction diode and low forward voltage drop as that of Schottky diode with surge handling ability. Middle dot point contact diodes. The construction of this diode is simpler and are used in analog applications and as a detector in radio receivers. This diode is built of N-type semiconductor and few conducting metals placed to be in contact with the semiconductor. Some metals move from towards the semiconductor to form small region of p-pi semiconductor near the contact. Middle dot Peltier diodes. This diode is used as heat engine and sensor for thermoelectric cooling. Middle dot gun diode. This diode is made of materials like gauze or ink that exhibit a negative differential resistance region. Middle dot crystal diode. These are a type of point contact diodes which are also called as cat's whisker diode. This diode comprises of a thin sharpened metal wire which is pressed against the semiconducting crystal. The metal wire is the anode and the semiconducting crystal is the cathode. These diodes are obsolete. Middle dot Avalanche diode. This diode conducts in reverse bias condition where the reverse bias voltage applied across the PN junction creates a wave of ionization leading to the flow of large current. These diodes are designed to break down at specific reverse voltage in order to avoid any damage. Middle dot silicon controlled rectifier. As the name implies, this diode can be controlled or triggered to the on condition due to the application of small voltage. They belong to the family of thyristors and is used in various fields of DC motor control, generator field regulation, lighting system control and variable frequency drive. This is 3-terminal device with anode, cathode and third controlled lead or gate. Middle dot vacuum diodes. This diode is 2-electrode vacuum tube which can tolerate high inverse voltages. Generic diodes, small signal and large signal. A PN junction diode is the simplest semiconductor device. It is a 2-terminal, bipolar, Unilateral rectifying device that conducts only in one direction. The generic diodes are used in the following fields. Middle dot rectification in power supply circuits. Middle dot extraction of modulation from radio signals in a radio receiver and in protection circuits where large transient currents may appear on low current transistors or ICs in interfacing with relays or other high power devices. Middle dot used in series with power inputs to electronic circuits where only one of negative or positive polarity voltage is desired.